Everyone, this is Cliff Wallach from RNK Distributing. I'm going to be hosting your webinar today on 3D printing and the long-term effects it is having on education and in other areas. RNK works closely with SNS Worldwide, who is hosting this webinar, as they distribute the Imaginator 3D printers, which you will hear about today. It's been a great partnership for us to be able to educate many of you on how 3D printers are being used today in classrooms and in after-school programs. I'll be presenting a lot of materials and giving you resources for the first 30 minutes or so of the webinar. And then we will be opening it up to questions. If you have a question you'd like answered, you can ask it in the Go to Webinar or put it in the chat and we'll address them towards the latter part of the webinar. I'd like to start by telling you about the webinar materials that you'll be receiving. You can receive after the webinar is done. We'll be sending them to everyone who is logged on and who remains. 3D printing is changing education and making a difference. I'm going to go through some learning objectives that we're going to cover today, and this is very basic ideas behind 3D printing and what kind of the history of 3D printing, some of the long-term benefits, how they're being used in education, classroom settings. I'm going to go through some of the resources that we've found online that are available to anyone, and that you'll be able to, again, receive after the webinar if you'd like, and some basic principles of 3D printing. This is an image of the Imaginator 3D printer. This is the printer. It's a dual extruder 3D printer with a heated build plate that SNS Worldwide is distributing. Some benefits in the long, big picture of 3D printing are things like mass customization, complexity, the fact that it is a toolless system except for the 3D printer itself. It's environmentally friendly, and it has positive effects on local manufacturing. So in mass customization, there are thousands of different things that are already made that people can download from the internet to print on their 3D printer, but they can customize them in many different ways, very simply. One idea of that is these telephone cases, in this case iPhone cases. These are all different designs that have been made that could be also enhanced using people's initials or names. You can put in school symbols or mascots. There are all kinds of different designs that can be added to basic designs. So this is something that, excuse me, this is something unavailable to the average person before, or even to institutions, to be able to customize all kinds of different things. And that's one thing that 3D printing is really amazing with. Complexity is something that 3D printing is absolutely changing right now. To make a very complex object in years past has taken massive machinery and molds and different ways of manufacturing, where now one can build something very, very complex on a 3D printer, which is really exciting. Toolless manufacturing. So there are extremely large tools all around the world for injection molding, CNC machines on the upper left side here, which is something that takes a solid object and peels away from it using lathes and different tools to specific specifications and specific designs. And they can do amazing things, these machines. They're absolutely incredible. But they're large machines. They take a lot of time and energy to use, and they're very expensive. So for a 3D printer to be able to make things that even some of these machines can't make, as far as the complexity is concerned, is pretty amazing. Environmentally friendly. Those large machines also have quite a bit of waste to them. CNC machines are, as I said, taking a solid object and then basically sanding and pulling away from that object to make a finished design, where all that stuff that is pulled away and taken off of the solid base is waste material. With large plastic injection molding machines, also there's a lot of waste material, especially in the starting and finishing of the machine when you're changing colors or when you're changing into different molds. Where 3D printing, here's a diagram on the lower right-hand side of this frame here. There's a solid component of plastic that is brought through a drive gear and is turned into a heated element that is deposited on a build plate and then built up on. And for that reason, there's little or no waste when you're using a 3D printer, which is very environmentally friendly. Of course, things that are manufactured all over the world have to be delivered all over the world, which takes tremendous amounts of resources. With 3D printing, when you're making one of an object that is specialized for a design or something that has been made that is custom made, you can make that one piece and it is there. It's already at the location of the manufacturing. Whereas if you're doing something, again, on an injection molding machine in China, it has to be manufactured in large quantities, thousands and thousands of pieces, and then brought to a port, put on a container, put on a ship, brought to the United States, put in a truck. So you can see that local manufacturing will certainly have long-term benefit for transportation costs and things of that nature. Some of the resources that we're going to go over on the webinar today come from Wikipedia. There's some sculptures and things that we're going to look at, different designs that have been made and printed in 3D printers. Again, these resources will be available to you at the end of the webinar so that you could either share them with people who may have interest like you in 3D printing, or people, or for yourself to do more research in the future. These are some videos that we're going to be looking at that have to do with 3D printers and their use in the classroom. And the SNF Education part of this webinar is that right now, maker spaces and the maker movement, where people are learning to design and manufacture original products, is right in line with different things that SNS has been selling and promoting for decades to schools and institutions. So if you're interested in getting more information, please contact Sandy Cervini from SNS Worldwide. Her email is here. And again, you'll get all this information at the end of the webinar. Right now, I would like to do a poll. We want to know how many of you are familiar with 3D printers. And if you could, I'd like for you to, the poll should be on your screen, if you could please answer what level of knowledge you have of 3D printers. It would be very helpful for us to understand for future webinars and education if there's more that we should be doing in greater detail. I know you're seeing just that on your screen right now. So in a minute, I'll open up other information that I'm going to be going through here. So let's see. Looks like a lot of people have written into their poll. Thank you very much. I appreciate it. I've got a couple more polls that we'll be doing later with other questions. So this is a very informational and interesting guide on the beginning of 3D printing and early history of 3D printing. It goes back as far as 1980. And 3D printers have been part of the manufacturing process for large companies for many years. Engineering firms, different types of architectural firms and marketing companies have used 3D printing, but those machines are quite expensive and have been not something that individuals or smaller institutions could really get their hands on or use. It was really in 2008 when an early desktop 3D printer systems were first available to individuals, and throughout the 2000s, the late 2000s, the prices have continued to drop, and that's one of the reasons that 3D printing is so prevalent right now and is being considered by schools and institutions. It's affordable for the first time in history, and it's a very easy technology in many ways. It takes some knowledge of 3D design and computers, but there are so many designs available out already in the world that people can download for free that it's actually a very inexpensive and quite easy to learn technology. So it works. There are many different types of 3D printers. Some of them are much more complex than others, but we do our 3D printer is a printer that designs from the base up. You build on a build plate and you deposit the melted filament, which is in our case, we mostly are selling a PLA, which is a cornstarch-based plastic, and it's a fused deposition modeling method. So if number 3 here on the upper right-hand side of your screen is the build plate, then number 2 is the melted filament, and number 1 is the extruder. So above that would be the solid filament and the heat element that heats the filament to a molten state, and then it comes out of the tip of the extruder at an exact rate, and then the extruder moves on an X and Y axis to cover whatever the design is. So this would be a simple design, and each of these circles would represent 2/10 of a millimeter or 1/10 of a millimeter in height. And the build plate, which is what this black base represents, would drop between 1 and 2/10 of a millimeter after each layer is deposited, and then the extruder would go over the design again, depositing the next layer. So in many ways, it's really 2D printing just over and over again, in that you're printing a 2-dimensional layer, and then the plate is dropping 1/10 or 2/10 of a millimeter, depending on what the program tells it to do, and then it deposits another layer. So this you could see where it could build a square very easily, or a rectangle in this case, but I mean a square piece. And it is important to note that when you build with angles that go up at an angle, as long as it's less than a 45-degree angle, it will build very, very nicely. But because it's a melted material, if you build at angles of greater than 45 degrees, the plastic will slump. And so there are some there are a few parameters by which building objects needs to be considered, but that's for a future webinar. That's a little bit more advanced than what we're doing right now. So there's a website. Sorry, this is the 10 Principles of 3D Printing. Is an article regarding 3D printing, and we went over 5 of these when we talked about how they are toolless, and they're local, so they're good for the environment and things like that. So this is another resource for people who are interested in 3D printing, who are maybe teaching actual 3D printing classes. This is a good resource as well that you can use. There's a website called Thingiverse.com. Thingiverse.com is open to the public. It's open source technology, and it's got over 100,000 different designs of all different types of models that people have uploaded that anyone can download for free. You have to sign a commitment to be a member of Thingiverse to not use the designs for profit. It's for nonprofit. It's for education. It's for personal use. Excuse me. And this is one example of something that a gentleman, a young man actually, uploaded of a DNA sculpture. And for STEM classes, for sciences, for math, for engineering, there are lots of resources on this site, Thingiverse.com, that teachers, educators, and students can download. And it basically gives you designs that can be used to enhance the educational experience in the classroom. So although 3D printers have been marketed in many ways as objects that can be taught in a classroom, in other words, an engineering class or a computer class, I think more importantly, and I think that's why it's important to learn about the basics of 3D printing, more importantly, 3D printers can be used to enhance STEM classes, to bring to life and to light different aspects of different parts of the class, and Thingiverse is a great place to do that. This is a 3D model of lactic acid. It's a molecule. and it shows the bonds between the different parts of the molecule. So for a chemistry class, this would be absolutely fabulous. For different science classes like biology, this is a human foot. And actually the way it builds, like I was saying before, how you can't build at big angles, it actually builds up from the base upwards, and it creates a human foot. Before I go to the video on stereographic projection, which is a really neat video on another aspect of how you can use 3D printing for sciences and for a classroom, I'd like to do one more poll. This is what do you do for a living? We're interested to know if we're speaking mostly to classroom teachers, to administrators, to different types of people. So again, so we know for future webinars what types of information we should be giving the people who attend. So we truly appreciate your putting in your vote on the poll on what you do. So let me load up this video here in the meantime. Give me a sec. So I'm going to close the poll now, and you should see a video on my screen. And rather than my explaining it, I'm going to let the gentleman who shot this video explain it. Here you go.
Hi, my name is and this is stereographic projection. Or rather, this is a sculpture that illustrates stereographic projection. So stereographic projection is a map from the sphere to the plane. And the way that it works is you look at the north pole of the sphere, and you draw straight lines from the north pole down onto the plane. Each such line hits the sphere once and hits the plane once. And so the map from the sphere to the plane is where does the line hit the sphere? That maps to where the line hits the plane. And why are we sitting in the dark? Well, straight lines are pretty well approximated by light rays. And so this is the light on my cell phone, which is a pretty good approximation to a point light source. And if you arrange the light at the North Pole, then the light rays effectively do stereographic projection. And these curves on the sphere are mapped to this straight line grid on the plane. This is stereographic projection.
So here's a principle of physics and light that can be explained to students of all different ages and grades and interest levels very simply, and enhanced through the use of 3D printing, because this is a design that can be printed on a 3D printer. I think it's exciting and interesting that as educators, there are tools that continue to evolve that will excite students. And I've been in the classrooms where the 3D printer has been running and making things, and the students I've seen grades 5 up to grade 12 be very interested in how it works and what they can do with it, and come up with ideas for what they can make, and get excited about the actual principles and properties of the printers themselves, but then take what they learn from it and apply it to their classes. I know classes that have done models of their school and the school grounds with students to actually teach 3D printing for an architectural or an engineering class. And then there are other places that have used science concepts to enhance the teaching in the school. So I'm going to line up another video here, and I want to. I just was reminded that it's possible that the videos will not be perfectly clear to everyone, depending on your connection to the internet and your baud rate for your computer. But the video, the sound for the video should be good and stream normally. So I apologize if the video doesn't look great to you. but I hope that the words and the information that it's imparting is very interesting to you. This is called 3D printing in the K-12 education.
Hello and welcome to 3D Printing in Education by Pathfinder Learning. In today's episode, we'll discuss how 3D printers are beginning to help educators in areas such as math, science, and civics begin to create their own classroom manipulatives. We'll begin by looking at Thingiverse, a website created for individuals to upload solid models to share freely with others. This page shows the many math manipulatives that have already been designed. Users can either download and print the items as they are, or can upload the files to their favorite solid modeling programs to make their own custom modifications. Recently, MakerBot, the host of Thingiverse, held a contest for educators and designers to create and upload their math manipulative designs. Many exciting designs were created during this month-long challenge. Designs ranged from a scale for performing math operations, a twisting math factoid, and a gear set which I recently printed. After downloading the files for free, I was able to print a finished product at a fraction of the price I would pay to retail distributors. This finished set will definitely come in useful for my upcoming lessons on ratios. Students can change out gears with 8, 16, 24, and 32 teeth for a variety of mathematical conversions. The next exciting site for manipulative STL files is AfricanFossils.org. The site was created by Louise Leakey of the Leakey family, who has been working for decades in the Rift Valley of Kenya to unearth a tremendous collection of human fossils. In an effort to share this work, they have begun scanning their collection. This site allows you to view the ancient skulls from virtually any angle with the capability of zooming in for closer inspection of detail and structure. Visitors are then able to download the STL file for 3D printing. A tangible set of the evolutionary phases of the human skull could be a welcomed addition in evolutionary biology classrooms. The Smithsonian has also been busy in scanning many of their artifacts to share with the 3D printing community. Smithsonian X3D is a site that has a collection of many of the Institute's more well-known items. Visitors are able to take virtual tours of each item while having full control of the object in 3D space. This particular model is of the blue crab. Biology students could make observations of these high-definition scans while learning about its anatomy and habitat, which is described in the side panels. Within the Smithsonian collection, students can also have access to a high-definition scan of Abraham Lincoln's life mask casting taken in 1865. After close virtual inspection, history students can download the file and print a physical model which can be scaled to a variety of sizes to display in their classroom. The next step in this process would be for teachers and students to begin creating their own custom manipulatives. This site called Tinkercad is a free solid modeling web-based application that is very easy to use. Students are quick to learn the controls to modify the parameters from a large bank of primitive shapes. Height, width, and length of the objects can easily be adjusted. They can also be rotated, lifted, lowered, and joined with other shapes to create more complicated figures. Lessons can involve challenging students to create 3D shapes while staying within specified dimensions. When the designing is finished, the user can download the file called an STL that is used by the 3D printer. Allowing the students to run software for the printer gives them the opportunity to learn about the process of slicing the model into two-dimensional shapes, which the printer then uses to create the hundreds of layers that go into making the objects. Students are often very interested in observing the paths the printer makes as a result of the algorithms which go into making each layer. As the students actively watch the printing process, they are better able to understand the limitations of the printer. This then translates into better design decisions. Objects with severe overhangs may require creative dissection to allow the design to lay flat on the print bed. By adhering to design restrictions, students get a taste of the same constraints professional engineers face. Students get definite feedback when they are able to physically hold and inspect the figures they created using computer software. Here is a list of the sites mentioned today. I have also included Umagine, which, like Thingiverse, is a free and open repository of design files to download for 3D printing. The following is a list of free solid modeling programs. OpenSCAD is a parametric modeling software which is best suited for more advanced students. Tinkercad is very easy to use and could be used in classrooms ranging from 3rd to 12th grades. Finally, Blender is a very full-featured 3D design software which would work well for older students serious about design. Be sure to check in with pathfinderlearning.org and my YouTube channel to see more videos and tutorials on progressive applications of the latest technology in K-12 classrooms.
So I especially love that video because of the use of the printing of the pyramid that they do. So if you were watching, you would see all those layers formed, and of course it was sped up so that it doesn't, because it does take time. 3D printing is not the fastest process in the world. It is slow and steady, and the fact that they show that those lines going back and forth and the layers building up, and I think that's really it's really interesting for those of you who haven't seen 3D printers before and haven't played with them before, which actually gets me to my next poll, which is, do you have a 3D printer in your institution? Do you already have a 3D printer in your program? Those of you who do, and then you know a lot of the things I'm talking about already probably, in which case I hope I'm not being too repetitive, but this is a basic 3D printing webinar. We're talking about the basic rules and ideas and trying to introduce people to it. And if people want, we would do more detailed webinars in the future. So this is on Thingiverse. When I close the poll, you'll see that my screen has a math spinner on it, which is that math spinner that he discussed in the last video. So it's a very simple print that you put together in pieces. It's part by part. And then you can do basic mathematics with it. Multiplication, division, subtraction, addition, equals, up to 99. And kids, of course, could print it in different colors and mix and match colors if they wanted to, and have a really fun and easy engineered object that they made themselves that also helps them with mathematics, which I think is just fantastic. So the next video that I want to show is, excuse me one moment, I'm sorry. Just got to find it on my computer here, is from a school system in Fargo, North Dakota that has adopted 3D printers and are using them in their programs. And I think it's very inspiring, and I hope that you'll be inspired by it as well. Hold on one moment.
My name is Alexis Yoakum. I am a technology education teacher at the middle school level in Fargo, North Dakota. The class that I teach is different from every other class. We show them how different technologies work together. I saw a natural progression from our drafting to our CAD to 3D printing. 3D printing has the potential to make a significant change in the way we do things. Fargo 3D Printing believes that they should come alongside and support what's going on in the classroom instead of the 3D printer being the focus. They were willing to have a conversation with me to help me. They were willing to help give advice to see different aspects of 3D printing. Make it something that they can say, I need this I'm using. And we need to think about what it is we are going to do with the technologies, because they have grown up with technology. While it's fun for them, it's interesting, they don't realize how far we've come in the last 15 years or less. If you don't learn about technology, you're not going to be on the cutting edge of the next cool thing. These kids, they need to think about that, because that's what their life is going to be. The farther along we get in time, the more technology we use, and that means more technology in our everyday lives, and they start using it earlier. And I want them to be good stewards of it. The 3D 3D printer is driving these kids to doing something which they will probably use later on in life, maybe in a career, but they're learning how creative they can be. It's very important to show them that they have that opportunity to guide and steer the technologies that are coming their way.
So there is something where you've got a classroom and an educator who's dedicated to using 3D printing and 3D modeling in her curriculum, and that's really exciting. And that's another layer in what one can do with 3D printers. A lot of schools such as that are putting a bank of 3D printers in a room where they have, because of the way 3D printers most 3D printers work now, and our 3D printers work, the Imaginator 3D, you take an SD card that you write a file to that's been sliced and properly and set up to be printed, and you walk over to a printer with that SD card and an available 3D printer and load that card into it and then print the file. And as I said, it takes some time. So often they'll have a class where they'll be designing, and then certain students in that class will be responsible for setting up the prints and getting them going before the end of the class and making sure that they start properly. That once a print starts well, then they have a tendency to also finish well, as long as the filament quantity in the back is loaded properly, and there's no problems with electricity in the room and things like that. But for the 3D printer to get going, it's important to have someone watch over it and make sure that the print that was designed and loaded into the computer is set up properly and works well. And if it doesn't work well, it'll be obvious very early on in the print. So that's a really neat one. This next video is enhancing science through engineering, and it's more involved because it's not to do so much with one teacher as with many, which is really exciting. Hang on just a second, here it is.
It's not just a problem on a worksheet, it's actually something that I can use. It's really neat how all of a sudden like everything just became one. We're reading a history document, and then it's like, okay, use that to draw up this, and then oh, that makes sense because we did the electromagnet, and then oh my god, like all of a sudden the kids were like, it was just all so natural.
We both really understand electricity much more than we would say we made an electromagnet or a thing of paper.
Originally, we were talking to UVA and about 3D printing and then using engineering to enhance science curriculum. And we heard about the Smithsonian pushing a 3D initiative, and so we collaborated with UVA to have students create a telegraph. Really, it was sort of an open-ended project, and the telegraph was a natural fit for some of the stuff that Robbie is doing in his class. It fit in with the science curriculum really, really well, electromagnets, and then with the stuff and the open-ended things we can do in the engineering classroom, it sort of became this, easy collaboration, and it was like, okay, you do that, I do this, and then boom, and he taught the content at first, and then I started teaching the kids how to do some of the design work.
We learned a lot about how the veiled telegraph was used, like during the Civil War, why they needed relays, so like if the electricity were to burn out, the relay would keep the fresh electricity going. It was nice to not only just make it for no reason, but really like learn how it was used.
UVA contacted the Smithsonian and wanted to present it to the Smithsonian, and so we were actually invited up, and the students presented it to the bigwigs up there,
and they were so impressed with it all that they wanted to continue collaborating with us and seeing how we could actually do this with all sorts of other innovations and inventions that are archived in the Smithsonian.
So this is the team. It has its own power source. Yeah. And so when you click this, it sends electric signal here into this iron core, and then when the electromagnets are turned on, it pulls this down, which completes the secondary circuit, which then turns on the light. And makes a very satisfying looking.
Really, my job in my classroom is to teach the science and apply the science and do some type of minor engineering. Eric's job is to teach the design and engineering aspect of it, and through that to enhance the science class.
I learn better when I'm experiencing it in front of me. Like reading and taking notes from the textbook, it doesn't help. It's just easier to understand something if it's right in front of you, and you can do different things to it or whatever it is, and like you can just see the reactions of it. It's simpler. You can make relations.
Absolutely, they're learning, and you know, if our concern should not be can a kid accurately answer A, B, C, or D. I mean, it should be like what skills are they going to be able to really apply and use in life? And I don't see test taking as the number one skill I want my kids to walk away with. I want them to be critical thinkers, problem solvers, and be able to apply knowledge. If you can't apply knowledge, it's not very helpful. I think that's what schools need to become, is a factory of individual critical thinkers.
So that is a very interesting group of people who are working to use technology, existing technology, and probably continuing with newer technologies to teach students how to think critically and how to learn using 3D printers and 3D design. And it's just another level of education that was unimaginable only 10 years ago or 5 years ago even. So it's incredibly exciting. I'm hopeful that you've found this to be very interesting. I have one more poll that I would like to run by you. Would you be interested in learning more about 3D printing? Also, if you have any questions for me to answer, you should be able to type them into your screen, and I have coworkers on the line who will forward them to me, and I can answer them for you over the telephone individually. Of course, if you have questions about actual Imaginator 3D printers, I hope that you'll get in touch with SNS Worldwide, and that they can work with you for your needs in your area. So the webinar, except for questions, is finished. You'll have it available. You'll have these resources available to you if you wish to see them after the webinar. They'll be sent to everyone who was a participant. That way, if you have more research you want to do in any particular area, or you want to look through Thingiverse.com and look for, there's a search function on there where you can put in so many different options, and it will give you so many different things that you can look at. It's absolutely amazing. Let me see if I can get to Thingiverse.com. If you search dinosaurs, it's just amazing, the different details and different, I mean, from fun to soap dishes and funny, and to factual, like the T-Rex skull. There are dig images for fossils, Triceratops, all kinds of different wall hooks. There's an amazing mixture of fact and fiction and items of interest that one can find on a place like Thingiverse. And Tinkercad is a very, very interesting program that if we do another webinar, that's something that we'll certainly be looking at. It's a very easy to use, drag and drop 3D design program. So let me answer some questions here that I've got that have come in. One person has asked, how hard is it to set up the Imaginator 3D printer? So it's very easy to set it up. It's easier than a sewing machine, a little more difficult than a regular printer that you would get for your computer, a paper printer that you get for your printer. It comes with step-by-step instructions, a manual, a quick setup manual, and then a more detailed manual as well. There are 2 screws that have to be attached to get the extruder head attached to the carriage that drives it around where it needs to be. And after that, it's really just it's push and play. Very, very easy. It also has instructions on how to download builds from the internet, download different designs, and get them onto the SD card in the manner they need to be so that the printer will run them. I have another question here. What type of filament can I use? So we sell both PLA and ABS filament. PLA is, again, a cornstarch-based plastic. It's considered to be an environmentally friendly plastic because it is biodegradable. It is strong, but ABS is stronger. We sell more PLA than ABS, especially to schools and homes, because PLA melts at a lower temperature, and also the build plate, to make it stick to the build plate, the build plate does not need to be heated as warmly. And so for classrooms and for younger hands, it's much more easy to use PLA. The next question I have is, what is the maximum size of a 3D print on the Imaginator? The maximum build size is 8.9 inches by 5.7 inches wide by 5.9 inches high. So basically 9 by 5 3/4 by almost 6 inches high, which is a good size build plate. It's a dual extruder, which means you can print 2 different either color filaments or 2 different types of filament, which is another aspect of 3D printing that makes this printer very interesting, because there are filaments that are being experimented with, such as wood filaments that we've used on our printers that work very well. There's PVA, which is a polyvinyl alcohol filament, which is water soluble. So with 2 extruders, you can make much more complex builds and use the polyvinyl alcohol filament in between and under the PLA or ABS filament as a structural base, and then wash it away when you're done. So I've got a question here. Is there any way to reduce the time of 3D printing? At this time, for this type of 3D printing where it's built layer by layer, it is rather slow. And the reason it's slow is because it's just going 1 layer at a time, 0.2 or 1/10 of a millimeter, depending on the quality of the print that you plan to do. And there are ways to adjust the speed rate in the machine and in the designs, but basically it's by making a less quality print, something that's not as high quality, so a 0.2 of a millimeter layer instead of a 1/10 of a millimeter layer, for instance. But I think that over time there are going to be 3D printers that are faster, but the price of those may be a consideration that would make it difficult. How can we teach children ages 8 to 15 to use 3D printing? That's a great question. There are so many resources online right now. The resources that you'll be sent after this webinar will point you the way. I strongly suggest that you visit the Tinkercad site. It's either tinkercad.com or autodesk123.com. Also, I suggest you use either Google Chrome or Safari as your browser for those sites. A lot of the 3D printing sites do better with those browsers for some reason. 8 to 15-year-old children are still full of imagination and unlimited positivity. And if we can show them what they can make with 3D printers and what they can potentially build with 3D printers, and then teach them the basics of 3D design through a program like Tinkercad, and let their imaginations run wild, it's amazing what they can do. One of the really neat things about Tinkercad that I love for younger kids is that when you finish a design, you can export it for 3D printing, or you can export it to Minecraft. And if any of you have younger children or even mid-teen children, they may play Minecraft from time to time. And it's a 3D reality program which is quite realistic, but everything's in blocks. You can, I've seen a young man who created a castle in Tinkercad and exported it to Minecraft and brought it into the game and ran around the staircases and the statues and the turrets that he designed in Tinkercad on his computer screen while he had a printout of the castle next to his computer screen. So there are more and more ways to bring young people, 8 to 15 is like the perfect age group, into using 3D printing. It's absolutely amazing. The next question is, do you have a particular printer you recommend for school buying its first 3D printer? I recommend the Imaginator. I hope you'll contact SNS regarding it. It's a very easy to use and easy to maintain printer, which is one of the reasons that we love it. We have printers that we've experimented with that have run for well over 1,500 hours and have needed very little, if any, maintenance in that time. It's easy to run, easy to maintain. They're fun to use, and they're going to be around for a long time because they have dual heads. So when there are new filaments created in the future that need to be melted at a higher temperature or at a lower temperature, or they need a warm build plate to stick them down and make them really easy to build on, this printer will still work for you. It's absolutely, it's a very easy to use 3D printer, and I suggest that you start with something similar to it. There are very expensive 3D modeling machines that are available. Some of them are quite technologically advanced, and I've seen schools that have had enough problems with those very advanced machines because for the younger students or even middle grade students to use them, younger high school or older middle school students to use them, it can be very complicated and there can be problems as a result. There are some amazing machines other than the Imaginator 3D printer, of course. There are a lot of options out there, and it depends on whether you want to build one from scratch with your class, make it as a kit project, or whether you want something that just comes in a box like ours and you can set it up and start using it the same day. I really appreciate everyone who signed on to our webinar. I'm going to end it now. Thank you for all of your questions. I will be speaking with my coworkers and partners over at SNS to see if we want to do more webinars in the future. We'll have to look at the polls and see what everyone said. And I hope that I've informed you about 3D printing and that you've learned something today, and that you will look through the resources that SNS provides and consider using 3D printers to entice your students to have different learning experiences. Thank you very much, and have a wonderful day. Good night. Bye now.